minutes, and if you have extra time, feel free to. Hi friends, welcome to our lesson. I'm Mrs. Gradney, and today in our lesson, we'll be using what we know about drawing area models to show equivalent fractions to learn a new way to show equivalent fractions using multiplication. Are you wondering how we might use multiplication to show equivalent fractions? Well, let's get started. Let's start with what we already know. And we already know how to draw an area model to show a fraction. So pause the video here and draw an area model and shade and label it to show 1/3. Remember to try to make your units as equal as you can, but they don't have to be perfect. I'll be here when you get back. Welcome back. Here's my area model showing 1/3. Does yours look similar? Check to make sure you remember to label the hole. Now let's draw a horizontal dotted line across our area model like this. Now, what happened to the size of the fractional units? Pause the video to talk out your thinking. You probably noticed that the fractional units got smaller. You might even be thinking that the fractional units are now half the size that they were before. What happened to the number of units in the whole? Pause the video to talk out your thinking. Well, to begin, we had 3 units in the whole, but when we drew that horizontal line, we broke each of those units into 2 parts. So now we have 6 units in the whole. We decomposed each third into 2 smaller units. So the number of units in the whole doubled. Or we could say that we have 2 times as many units in the whole. What about the number of selected or shaded units? Well, when we started, we had 1 selected unit, but when we drew that horizontal line, we decomposed that third into 2 parts. So we decomposed it into 2 smaller units. So the number of selected units also doubled, or we got 2 times as many selected units. So now we can see with our area model, we're showing that 1/3 is equal to 2/6. Now this is what we already know. Let's see how we can show what happened to the units with multiplication. Okay, we started with 1/3. In the beginning, we had 3 units in the whole. When we drew that horizontal line, we got 2 times as many units in the whole. Now we have 6 units in the whole. We made 6ths. In the beginning, we had 1 unit selected. When we drew that horizontal line, we got 2 times as many units selected. Now we have 2 units selected. So now we've shown with multiplication that 1/3 equals 2/6. Now, when we made 2/6, this fraction here, using multiplication, did we make a larger fraction? How do you know? Pause the video to talk out your thinking. Hopefully you said, no, we didn't make a larger fraction. We didn't shade any more of the whole, so the fraction of the whole that's selected is still the same. We didn't change the size of the fraction, we just changed the size of the units used to represent that same amount. 1/3 is equal to 2/6. Or in other words, we just renamed 1/3 using a different unit. Let's try another one. Pause the video and draw and label an area model to show 1/2. Welcome back. Here's my area model showing 1/2. We can see the whole figure represents 1 whole, and the fraction 1/2 is shaded and labeled. Does yours look similar? Now, what if we wanted to rename 1/2 using 4 times as many units? What could we do? Right now we have 2 units in the whole. What would 4 times as many units be? Then we would have 8 units in the whole. So I'm thinking, how could I draw some horizontal lines to make 8 units in the whole, to make 4 times as many units? Pause the video and give it a try. Then come back and compare your model with mine. Here's my area model showing 4 times as many units. To make 4 times as many units, we needed to draw 3 horizontal lines. Now, when we drew those horizontal lines and decomposed the halves, what happened to the size of the units? The units got smaller. Here's the size of 1/2, which was our original unit, and here's the size of our new smaller units. What happened to the number of units in the whole? We got more units in the whole, didn't we? At first, we had 2 units in the whole. Now we have 8 units in the whole. So we made 8s. That means the number of units in the whole quadrupled. That's 4 times as many units in the whole. What about the number of selected units? Well, we started with 1 selected unit. Now we have 4 selected units. So the number of selected units also quadrupled, or got 4 times as many. Now, has the size of the shaded area changed? No, the size of the shaded area hasn't changed. There are more of the smaller sized units instead of 1 larger sized unit, but the shaded area is the same. So what does that tell us about 1/2 and 4/8? 1/2 and 4/8 are equal. Way to go. Now let's show what happened to the units using multiplication. We started with 1/2. In the beginning, we had 2 units in the whole. And when we drew those horizontal lines, we got 4 times as many units in the whole. Now we have 8 units in the whole. In the beginning, we had 1 unit selected. And when we drew those horizontal lines, we got 4 times as many units selected. Now we have 4 units selected. So we've shown with multiplication that 1/2 equals 4/8. Now, I'm noticing something. When we quadrupled the number of units in the whole, the number of selected units also quadrupled. In our last problem, when we doubled the number of units in the whole, the number of selected units also doubled. What do you predict would happen if we tripled the number of units in the whole? Pause the video to think about that and explain your prediction. I bet some of you said that if we tripled the number of units in the whole, the number of selected units would also triple. Is that what you predicted? Well, let's test it out. Now, I want you to try this on your own and test your prediction about what would happen if we triple the number of units in the whole. Take a look at this fraction model. In the fraction model, we can see that the whole rectangle represents 1 and 1/4 is shaded and labeled. Pause the video and draw this model, and then draw horizontal dotted lines to make 3 times as many units, or triple the number of units in the whole. And think about what you notice. I'll be waiting when you get back. Welcome back. Here's my area model showing 3 times as many units. How did you create 3 times as many units? Hopefully you drew 2 horizontal lines like I did to create 3 times as many units. Now, when we drew those horizontal lines and decomposed the fourths, what happened to the size of the units? The units got smaller because we decomposed the fourths into smaller units. What happened to the number of units in the whole? Well, we had 4 units in the whole, and now we have 12 units in the whole. The number of units in the whole tripled. We got 3 times as many units in the whole. What about the number of selected units? Well, we started with one selected unit. Now we have three selected units. So the number of selected units also tripled, or we got 3 times as many selected units. Is that what you predicted would happen? If so, way to go. That means you're noticing math patterns. So, from our model, what fraction can we tell is equivalent to 1/4? 1/4 equals 3/12. Now, let's show what happened to the units using multiplication. But this time, I want you to try it on your own. Pause the video and complete the number sentence to show that 1/4 is equal to 3/12 using multiplication. We'll go over it together when you get back. So here's how we could have shown that 1/4 is equal to 3/12 using multiplication. We started with 1/4. So in the beginning, we had 4 units in the whole. When we decomposed those fourths, we got 3 times as many units in the whole. And now we have 12 units in the whole. In the beginning, we had 1 selected unit. But when we decomposed those fourths, we got 3 times as many selected units. And now we have 3 selected units. So we've shown with multiplication that 1/4 is equal to 3/12. Great job. Denominator is a special word that we use to describe the fractional units. Everyone whisper denominator. So 4 is the denominator in 1/4, and 12 is the denominator in 3/12. How is the denominator 12 in 3/12 related to the denominator 4 in 1/4? Pause the video to explain what you're thinking. You may have said the denominator in 3/12 is triple the denominator in 1/4. That makes sense because we got 3 times as many units in the whole. How about the numerators? Everyone say numerator. Here, we've been saying the number of shaded units or the number of selected units. The special math word for the number of selected units is numerator. So what's the relationship between the numerators in 1/4 and 3/12? You may have said the numerator 3 in 3/12 is triple the numerator 1 in 1/4. That makes sense because we got 3 times as many shaded parts. It's the same relationship as the denominators have. Now, we've been using multiplication along with the area model to create equivalent fractions. Let's try it now without using the area model. Pause the video and create an equivalent fraction for 1/3 using multiplication. Once you've done that, you can verify or check to make sure that the fractions are equivalent by drawing an area model, if you need to. When you get back, you can check your work with mine. Welcome back. I'm going to show you some of the ways that you may have created an equivalent fraction for 1/3 using multiplication, but I'm not going to show you all of the ways that you could have done it. Maybe you doubled the number of units in the whole and doubled the number of selected units to find that 1/3 is equal to 2/6. Or maybe you tripled the number of units in the whole and tripled the number of selected units to find that 1/3 is equal to 3/9. Or maybe you quadrupled the number of units in the whole and quadrupled the number of selected units to find that 1/3 is equal to 4/12. Could you have also found 5 times as many units in the whole and 5 times as many selected units? Or 6 times as many? Absolutely. All of those would create equivalent fractions. Excellent work today, friends. Now you're ready for the problem set. On the screen are the must-do problems. Work on these problems for 10 minutes, and if you have extra time, feel free to try any of the other problems. Today, we drew area models to create equivalent fractions, and we related that to using multiplication to create equivalent fractions. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson.